It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, welcome to lesson 6 here where we're going to graph linear inequalities. So today's a graphing lesson where we're going to be dealing with inequalities this time. So we're going to be dealing with less than or equal to and greater than or greater than or equal to. So determine if the following points are solutions to the inequality. Well, you're only a solution if you make it true. So let's take the point 3, 2, and I'm plugging that in for x and y. 4 times x minus y, is that less than or equal to 10? Well, 12 minus 2, is that less than or equal to 10? Yeah, 10 is less than or equal to 10. So this point is a solution. Let's try the next one. Negative 3, 4. Plug in a negative 3. Plug in a 4. Is negative 16 less than 10? Yes, it is. That is a solution. 0, 0. Plug it in. 0, is that less than or equal to 10? It is. So far, all of these points are solutions to this equation. Let's try the next one. 4, negative 1. 4 times 4 minus negative 1. So I'm just plugging in x and y. 16. Ooh. Not a solution. That point right there is not a solution. It didn't make it true. All right, another row. Let's pause the video here and see if you can do these on your own. So check your work with my bottom row there, pause the video, and see if your solutions match up. So I got yes, yes, no, and yes. So what we do is we're going to be graphing all of these points. So all of these points that are solutions lie on the graph. To be part of the graph, you have to be a solution. So let's look through these here. I got 3, 2. That point works. Negative 3, 4. Negative 3, 1, 2, 3, 1, 2, 3, 4. 0, 0. Now that one doesn't work. I'm going to switch colors and make that an X. What is that? 4, negative 1. 4, negative 1, no good. It's like you sunk my battleship there. Back to the pink color, this magenta-y violet color. 5, 10 over 5. 1, 2, 3, 4, 5 up 10. 0, negative 10, good. What else do we got? 6, 0, no good. 1, 2, 3, 4, 5, 6, 0, no good. 1, negative 6. 1, negative 6 was good. 1, 2, 3, 4, 5, 6. So those are some of the points. I have to plug in all of these points to check it out. But let's look at this inequality. 4x minus y is less than or equal to 10. Notice that this equation is a solution. Can 4x minus y equal 10? Well, yeah, I have that equal to. So let's graph this line. Basically, when we graph an inequality, we're really graphing a line. So I'm getting y by itself, like I always do. Divide by negative 1. Y equals 4x minus 10. So notice this line is a solution. Any point on this line also works for the inequality. So let's graph this line here. Start at negative 10, and then I have a slope of 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4. So all these points on this line that I'm going to draw in right now in black works. Any point on that line is a solution. But notice, it's not equal to. I didn't deal with equal to here. I'm dealing with an inequality. So instead of saying equal to, I'm going to say less than or equal to. Less than or equal to. And here's the problem. I just divided by a negative. Warning, warning, warning. When you divide by a negative, the inequality gets flipped. So it's really y is greater than that. So here's what we do. Notice the purple points are on this side of the line, and then the orange you sunk my battleship points are on this side of the line. So notice any point on this side of the line is a solution. So when we graph an inequality, we're really graphing a half plane. We're graphing half of the coordinate plane. I need a lie anywhere on this side of the line to be a solution, because that's where the solutions were. Anything over here in this orange part will not be a solution. So when we graph inequalities, we shade a half plane. We shade the graph of an inequality is actually a half plane, and we're going to practice graphing these today. So graph each inequality below. So let's graph them. Y is less than 2x minus 1. So the first step is graph the line. We got 3 steps here. We got to graph the line. Pretend it's equal to, and we'll graph the line. So I start at negative 1, and I have a slope of 2. Up 2, right 1. Down 2, left 1. All right. But watch. Can I actually equal it? It does not have the equal to, right? This is a strict less than, whereas before I had the or equal to. So I can't be on this line. And the way that we represent that is with a dash. There's no equal to, so I don't actually have solutions on that line. So you have to decide, do I want a solid line or do I want a dashed line? Do I actually want to include that value in the solution set? So I don't want those to be in the solution set. Sitting on this line is equal to. I don't have that equal to. So solid 2 is when you have the equal to, dashed is when you don't. And then the last step is to shade the half plane. The last 4 does not come after 2. 3 comes after 2. The last step is shade the half plane. That's what we have to do here. Which side am I shading? And here's how we figure it out. I have y is less than, so I pick any point. And I need to decide, do I shade up vertically or do I shade down vertically? In this case, I'm shading down vertically because I have less than. So this is the side that I want to shade. As I sneeze, this is the side I want to shade. This is my graph. So I graph the line. Then I go solid or dashed. Do I actually draw on the line or do I do a dashed line? And then I have to pick which half plane to shade. Do I shade vertically? It's always vertical. Don't think left or right. Left or right's not good to think about. Vertically up or vertically down. In this case, I want to go down to this part of the graph. All right, let's try this one here. Same steps. Pretend it's a line. Let's graph that line. Start at 2, slope of negative 1/3. Down 1, right 3. Down 1, right 3. Draw in that line. I didn't pause. That's what you guys have to watch out for that. So I have to ask myself, is it solid or dashed? Can I equal it? Yes, I can. So that solid line is actually okay. This other line wasn't solid because it doesn't have the equal to. It doesn't have the equal to. And then finally shading. Y is greater than. So pick any point. Am I going the up arrow, the upside, or the downside? Well, it's greater than, so I'm going the up arrow wins. This is the half plane that I want to shade. I don't want to be shading that lower part there. There's a lot of little things to look out for when we do inequalities. When we work with inequalities, there's a lot of things to look out for. Oh, this is not y equals, so let's get that done. Let me add that 3x over. Negative 2y is less than 3x plus 6. And then divide by negative 2. Uh-oh, I just divided by a negative. Warning, warning, warning. Notice my inequality flipped. Negative 3 over 2x minus 3. Start at negative 3. 1, 2, 3. And then from there, I have a slope of down 3, right 2. I have a slope of down 3, 1, 2, 3, right 2. 1, 2, 3, right 2. Or up 3, left 2. Before I draw in that line, I'm going to ask myself, should I be drawing in that line? And the answer is no. There's no equal to, so I actually cannot draw in that line there. These points are not solutions. I can't, that's like that boundary line. It's like an electric fence. I can't touch this one. That's why it's dotted there. I can't actually sit on that line. And then we shade. Y is greater than. So I decide, am I shading vertically up or vertically down? Well, greater than means go vertically up to this side. So this half plane is my solution. That half plane there is my solution. Last one here. I'm going to distribute. Y minus 5 is less than or equal to 1/2 x. Half of 3 is 1.5. I'm going to add 5 over. Y is less than or equal to 1/2 x plus 3.5. So I'm going to start at 3.5, 1, 2, 3.5. 1 over 2. Up 1, right 2. And notice I'm in the middle of these points here because I'm dealing with that half. Before I draw this line in, let me check. Solid or dashed? This one is solid. This is a solid line here. So I actually need my ruler for this one. Solid line. Which way do I shade? Y is less than. Y is less than goes down. Less than goes down this way. There's my graph. Okay, do not color it in like that. That drives me crazy. We draw these lines. We draw those lines coming out of that original line. Okay, let's go backwards. Here's a graph. Tell me what the inequality is. So here's a graph. Tell me what the inequality is. Well, let's pretend it was a line. Let's do y equals mx plus b first, and then we'll deal with the equals. So y, well, my y-intercept's easy. 1, 2, 3, plus 3. What's my slope? Well, down 1, right 2. Down 1, right 2. That's if it was a line, but now I need to decide what goes there. Well, it's not equal to, right? Of my options here, I'm getting rid of those equal to ones because of the dashed. And now do I shade up or down? Well, I shade up, so y is greater than. This is a greater than inequality because I'm shading up. So we can work backwards. Given a picture, we can find an algebraic representation of the inequality. Same thing here. Let's pretend y mx plus b. So my y-intercept is -1. My slope is 3x. Right? Up 3, right 1. Up 3, right 1. What goes here? Do I shade up or do I shade down? I shade down, but it's not, I can actually sit on that line, so I'm going to put an or equal to there. So you have to keep track when you deal with these inequalities of solid, dashed, equal to, not equal to. All right, I'm going to end the video there. We've got some more problems to do, but we'll talk about those in class. The big idea is we graph the line. That's step 1. But before you finish graphing that line, you have to decide, is it solid? Do I have the equal to pieces? Or is it dashed? Is it less than or greater than? And then finally, you need to shade the half plane. Which way am I shading? Am I shading up or am I shading vertically down? And I'll see you guys in person.